Good morning, all of you. My name is Sheikh Kalesha. So I am HOD in Mathematics Department of the team PU College. Down after 5 minutes break, we will take class chapter for case set. Case set. So maximum they given 3 to 4 bits given for JE also from this chapter 1 or 2 questions given. But this is a concept oriented, easy only, but some little bit calculation part there. So now we will discuss today in this session completely that concept of matrices. So already we know that matrix definition in board also. Matrices or matrix. Okay, now what is the definition of matrix? What is the definition of matrix? What is the definition of matrix? So here matrix is nothing but a rectangular arrangement of numbers. A rectangular arrangement of numbers. A rectangular arrangement of number in some rows and columns. In some rows and columns. A rectangular arrangement of numbers in some rows and columns. Here, rectangular arrangement of number. Number means which number we can choose. Maybe real or complex number. Maybe real or complex number. For example, we can choose the number 2, 4, 3. We can choose the numbers 2, 4, 3, 0, 1, 2 plus I. So this is the complex number, and 0, minus 1, 3, 7. Here we can choose some real and complex number. These numbers can be arranged in some rows and columns. Some rows and columns. So this arrangement is called matrix, but this arrangement we enclosed between two types of brackets there, open bracket or closed bracket. Now we can arrange this arrangement in this type of closed bracket, or sometimes we can arrange this arrangement of numbers in open bracket. Open bracket. But usually in our NCERT textbook or competitive exams, they can use the closed bracket only. Here see, these real or complex number can be arranged in some rows and columns. Then that arrangement enclosed between closed bracket or open bracket, then the structure is called a matrix. Now this is called what? A matrix. This is called matrix. Okay, this structure is called what? A matrix. So every matrix must and should have some rows and column. Here this horizontal line. Now this horizontal line there, no, these are called the rows. These are called rows. Then vertical lines. So 2, 0, minus 1, 4, 1, 3, 3, 2 plus I plus 7. These are called vertical lines are called columns. So sometimes if you are get confusion little bit in rows and columns, number of rows and number of columns. So that's why simply we remember the number of rows can be counted from top to bottom. Number of rows can be counted from top to bottom. So number of columns can be counted from left to right. Left to right. So in this matrix, how many rows and how many columns are there means here totally 3 rows there. 3 rows. And how many columns are there? 3 columns there. 3 rows and 3 columns. Then generally matrices are denoted with capital letters. So then matrices are denoted with the capital letter. For example, we can take matrix A is equal to A, B, C. Now in this matrix, how many rows and how many columns are there? In this matrix, how many rows and how many columns are there? So that's why if you are get little bit confusion, that's why simply we remember rows are counted from top to bottom. Rows are counted from where to where? Top to bottom. So top to bottom means 1, 2, 3. Number of rows is equal to 3. Then columns are counted from left to right. Left to right means how many columns are there here? Only one column there. So that's why this number of rows is 3 and number of columns is 1. So this is the simple way we can remember. So we can identify number of rows and the number of columns of the given matrix. Okay, so that is the matrix. Matrix is nothing but what? An arrangement, an rectangular arrangement of numbers in rows and columns. Then that arrangement enclosed between open bracket or closed bracket. Then the structure is called a matrix. Okay, now here we can choose the numbers inside of the any matrix. The numbers are called elements or entries. Elements or entries. Elements or entries. Now here, Sima, every matrix must and should be have some order. Order of a matrix. Order of a matrix. Order of a matrix. So what is order of a matrix? Is simple. So a matrix, for example, we can choose a matrix, a matrix, a matrix, We can choose here order of a matrix, order of a matrix. Here, Sima, a matrix, capital A is a matrix. That matrix has m rows and n columns, m rows and n columns. Then the order of matrix A, then the order of matrix A, O of A is nothing but order of matrix A is denoted by m by n. How do we pronounce this one means m by n, but here in between symbol there into there we can pronounce that value m by n value. So any matrix we can choose. Order of the matrix means first we can identify how many rows and how many columns are there. So the number of rows by number of columns is called the order of a given matrix. For example, we can choose A is equal to A is equal to, now we can choose here A is equal to this one 1 2 3 there 1 2 3. So now what is the order of this matrix means already we discussed how to we can calculate rows and columns. So simply we remember this one, number of rows, first we calculate number of rows. Rows are counted from top to bottom, so top to bottom. So row 1 row 2 row 3, so that's why number of rows is 3, and we can write down here by, into symbol is pronounced by, and number of columns left to right only one there. So that's why this matrix order is how much? 3 by 1 value. This matrix order is a 3 by 1 value. So whenever we can define order of a matrix, previous questions there on that CET concept they given previous question depends on that order also they given questions. So any matrix of order we can define means in the given matrix how many rows and how many columns are there. First we can search that number of rows and number of columns, then we can define number of rows by number of columns. That value is called, this value is called order of a given matrix, order of a given matrix. Okay na, order of a given matrix. So another point we remember, for example we can take A is equal to, matrix can be defined as Aij, this order is m by n. This order is how much? M by n value. This order is m by n. This order is m by n. Suppose A is equal to, we can write on here Aij. This matrix order is m by n. This matrix order is what? No? M by n. Now, what is the position of this element means Aij lies in ith row. This one what? No? Ith row and jth column. Ith row and jth column. Aij is the position of the element in the given matrix, that is represent ith row and jth column. So for example, we can choose the one matrix A is equal to, for example, 1 2 3 4 5 6 0 1 minus 1 there, 0 1 minus 1. So this matrix order is 3 by 3. Why? Here 3 rows and 3 columns are there, so that's why we can write on this matrix order is 3 by 3. And now we can find out the position of this number or this element. Then how to write on this sixth position means, now we can represent here how many rows on 3 rows and 3 column. So 6 lies in which position? 6 number lies in the second row and third column, second row and third column. So that's why this value second row and third column A23 can be represent sixth element. A23B can be represent the position of sixth element is A23, second row and third column. That is the position of the sixth element. So if you remember, generally we can consider any matrix Aij that ith row must and should be lies between 1 is less than or equal to I is less than or equal to m. J can be lies between 1 is less than or equal to j is less than or equal to m. So this is the position of the element in the given matrix. Okay, na? Right. So now we can discuss the two definitions here. One is the matrix definition, another one is the order of a matrix. So matrix means just what we recall here, a rectangular arrangement of numbers in rows and a column. So that arrangement enclosed between open or closed bracket, that is called matrix. Now after then we can define order of a matrix. So how to identify order of a matrix means any matrix we can choose, in that matrix how many rows are by how many columns are there, that value is called the order of a matrix. So another point, one point we remember here, important point. So depends on that order of a matrix, we can find out the number of elements in the given matrix means. So now a matrix of order, a matrix of order 2 by 3 given. If the order of A is equal to 2 by 3, then the number of elements in the given matrix A, then the number of elements, then n of A means number of elements in the given matrix is nothing but just we can take product of that number of rows and number of columns. That value is equal to how much? 6. So that is the number of elements in the given matrix of depends on the given matrix order. Okay, no? Right. Next we can discuss the conditions, types of next we can discuss set conditions, types of matrices. Here some different type of matrices there. Types of matrices. Types of matrices. Just now give you the example for these types of matrices. For example, first matrix is row matrix. First one, what? Row matrix. So which matrix is said to be row matrix? A matrix has, or a matrix contains only one row. A matrix contains only one row. So any matrix contains only one row, then that matrix is said to be ರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಏನೇನೋ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಒಂದೇ ರೋ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ, ಆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಏನಂತಮ್ಮ? ರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ. So that's why we can take here A is equal to this one 1 2 3 4. Now this is the row matrix. Already I told. So how to remember? Number of rows means counted from top to bottom. Here top to bottom ಮೇಲಲ್ಲಿ ಕೆಳಗಡೆ ಕೌಂಟ್ ಮಾಡ್ರೆ ಎಷ್ಟಿದೆಮ್ಮ? Only one row there. So that's why this is the row matrix. Columns so many are there, no problem. But columns so many given, but that matrix has only one row. That matrix is said to be row matrix. So that's why whenever row matrix order, number of rows must be 1. Number of rows must be 1. Here columns are 4 there. So 1 by 4 is the order of this matrix. Okay, na? So row matrix means what? A matrix has only one row, then that matrix is said to be row matrix. Now we go into the next one, column. Column matrix. So what is column matrix? What is column matrix? So column matrix is nothing but a matrix has only one column. For example, B is equal to, now we can write it like this, A, B, C. Now here see how many columns are there? Columns are counted from where to where? Left to right. Left to right. Here left to right, how many there? Only one vertical line. So that's why column is one. But rows are so many, means top to bottom 1 2 3 there. So that's why this can be represent always 3 by 1. In row matrix, number of rows is always 1. Column matrix, number of column is always 1. So that's why these are called row matrix and column matrix. So another one, singleton matrix. Singleton matrix. So what is singleton matrix? Singleton matrix. So singleton is nothing but only one element. A matrix contains only one element, then that matrix is said to be singleton matrix. So for example, we can choose here A is equal to here 3 element there. A is equal to which one there? 3 element there. So this matrix contains only one element, then this matrix is said to be singleton matrix. Now here question is, what is the order of this matrix? What is the order of this singleton matrix? How many rows and how many columns are there? Top to bottom we can count, then only one there. Left to right also we count, only one there. So that's why any singleton matrix we can choose. What is the order of that matrix is 1 by 1. What is the order of that matrix is how much? 1 by 1. This is the singleton matrix. So any singleton matrix we can consider. Then what is the order of that singleton matrix means 1 by 1 value. Okay, right. Simon, just we change that to font also. Now, then fourth one. So already we discussed the types of the matrices in row matrix and column matrix. Another one, what? So then this one is the singleton matrix. Singleton matrix means that matrix contains only one element. Now, this fourth one there. Next, null matrix. So this is very simple, null. Null matrix or zero matrix. Null matrix or zero matrix means any matrix we can choose. In that matrix, all elements are zeros. All elements are zeros. For example, O is equal to this one, 0 0 0 0 0 0 0 and 0 0 0. So here see how many rows and how many columns are there? 3 rows and 3 columns. 3 rows and 3 columns. So but every element should be 0. Every element should be 0. In any matrix, any element, every element should be 0. Then that matrix is said to be null matrix. Null matrix is denoted with the O letter. Denoted with the O letter. Okay, na? Suppose, for example, they given O2 given. That meaning what here? O2 means the null matrix is denoted with the order 2 by 2. Order 2 by O3 given means null matrix only denoted with the O3. Order 3 by 3. So this is the types of matrices. And another one here, rectangular matrix. Actually, this definition not there in textbook. Rectangular matrix means depends on that order. So, for example, we can choose one matrix. A is equal to, we can write on here 2, 3, 4, 7, 8, 9. 2, 3, 4, 7, 8, 9. So, what is the order of this matrix? Here, the order means number of rows, how many there? 2 there. So, number of columns, how many there? 3 columns there. Now, what is the order of this matrix means 2 by 3. So, number of rows 2, number of columns is 3. In any matrix, the number of rows is not equal to number of columns. In any matrix, the number of rows is not equal to number of columns. Then that matrix is said to be a rectangular matrix. Rectangular matrix. Then that matrix is said to be what? Rectangle. So why you are getting rectangular means that is the rectangular shape there. So number of rows and number of columns are different. Then that matrix is said to be rectangular matrix. Okay, na? Right. Next one, square matrix. Square matrix. Okay, square matrix is nothing but already we know that shape. Square means what? All sides are same. So like that only we can define one matrix here. A is equal to 1, 3, 4, 7. Here what we observing in this matrix, the number of rows is 2. Number of column is also 2. Then what we done here? 2 by 2. This matrix order is what here? 2 by 2 value. So by, so this order of the matrix is what we done means here. So this one 2 by 2 value. Here this order is a 2 by 2. So square matrix means what? In any matrix, number of rows is equal to number of columns. Then that matrix is said to be square matrix. Okay, na? So on depends on that square matrix, we can define that important definitions there in types of matrices only. Now this is the first one, row matrix, column matrix, and singleton matrix. Row matrix means already I told number a matrix contains only one row. Then that is called row matrix. Column matrix means that matrix contains only one column, that is column matrix. And singleton matrix means what? Any matrix contains only one element, then that matrix is said to be singleton matrix. Then what is the order of that singleton matrix means 1 by 1 value. Then after then we can discuss that null matrix. Any matrix, all elements should be zeros, then that matrix is said to be null matrix. After then we can write on rectangular matrix. In any matrix, number of rows and number of columns both are different. At the time that matrix is said to be rectangular matrix. Now what is square matrix? In any matrix, number of rows is equal to number of columns, then that matrix is said to be square matrix. Okay, na? So now this is the types of matrices, and in the types of matrices only another important definition there, principal diagonal. Principal diagonal of a matrix. Principal diagonal of a matrix. Generally, we know that in geometry, diagonal means just we can add the corners. Like that only here, principal diagonal means this principal diagonal only defined in a square matrix only. Let capital A be a square matrix. Let capital A be a one square matrix. Now here, Sima, A, B, C, P, Q, R, S, T, V. Some letters or numbers there in matrix. Okay, now this matrix order is 3 by 3. So 3 by 3. So 3 by 3 means this matrix is must and should be which type of matrix means a square matrix. Number of rows is equal to number of columns is means simply we remember that is square matrix. So here principal diagonal means in a square matrix the diagonal joining the first element in the first row, the first element in the first row to the last element in the last row, to the last element in the last row, that is called, this diagonal is called principal diagonal. So what is principal diagonal means? Principal diagonal only defined in a square matrix only. In rectangular matrix, principal diagonal does not exist. only square matrix only we can define the principal diagonal. So what is the principal diagonal means? In any square matrix, the diagonal joining first element in the first row to the last element in the last row, so that line is called principal diagonal. Now what is the elements in the principal diagonal means? A comma q comma v, these are the elements in principal diagonal. Now we can take b is equal to 1, 2, 3, 4. So this is a square matrix of 2 by 2. So in this square matrix, what is the principal diagonal means? We can join the first element in the first row, last element in the last row. This diagonal is called a principal diagonal. Then what is the elements in the principal diagonal means? 1 comma 4 are the elements in the principal diagonal. 1 comma 4 are elements in the principal diagonal of the matrix capital B. Okay, na clear ma this one? So this is the principal diagonal of the given square matrix. So after then we can define some important definitions in board oriented and competitive exam also important. So then first one is the diagonal matrix. What is diagonal matrix? So first one, what more here? Diagonal matrix. Diagonal matrix. Diagonal matrix. Sima. So this diagonal matrix only defined on square matrix only. A square matrix capital A, is said to be diagonal matrix if it's all outside principal diagonal elements are zeros. If all outside principal diagonal elements are zeros, the elements in the principal diagonal may or may not be zero. Means, for example, we can take one example here. A is equal to 0, 1, 0, 1, next 2, 0, 0, 1, 2, 0, or here another one number we can take by here. This number is suppose 4 there. Now what we define, Sima, in a square matrix, all elements are, so actually this one, now we can define, Sima, one square matrix. So that matrix A is equal to here 1, 0, 0, 2, sorry, this value is equal to 0 also, 1, 0, this value 0, and this value how much we write on here? 0 value. Now we can write on 4 value. Now in this matrix, what is the principal diagonal? This one is the principal diagonal. But generally in your textbook definition, NCERT textbook definition, diagonal matrix means what? In a square matrix, all elements are zeros except diagonal, principal diagonal elements. Except these two, these are also zeros. There means that matrix is said to be which type of matrix? Diagonal matrix. This is the 2 by 2 matrix, and 3 by 3 matrix we can consider means 1, 0, 0, 0, 2, 0, 0, 0, 3. Now here, Sim, this is the principal diagonal. In the principal diagonal, all elements are not zeros and the remaining elements all are zeros. Now this is the principal, this is the diagonal matrix. Simply we remember, diagonal matrix sometimes we defined as DIAG, diagonal of which one here? 1 comma 2 comma 3. So like this also we define, that is the diagonal matrix, diagonal of 1 comma 2 comma 3. Okay, now for example they given like this, given diagonal of 4, 7, 9 here. Now this can be represented in full form matrix. How do we represent means A is equal to, we can write on fast, 7, 4, 7, 9 and 0, 0, 0, 0, 0, 0. Now this is said to be diagonal matrix. This is the NCERT definition. But another competitive exam we can use that another definition there. Here already I told them, outside of the principal diagonal all elements are zeros. The elements in principal diagonal sometimes maybe 0 or may not be. Maybe 0 there means that element, that the matrix is also called which type of matrix means diagonal matrix. That matrix is called diagonal matrix. That matrix is called diagonal. For example, C is equal to, we can write on my here, C is equal to 0, 0, 0, 4. This is also a diagonal matrix. Why I told? here principal diagonal elements may or may not be zeros. Okay, now that is the competitive, we can use that condition. Sometimes all are zeros. Null matrix is also a diagonal matrix. Null matrix is also a diagonal matrix. So that is the definition of diagonal matrix. In a square matrix, all elements are zeros except the principal diagonal element. Then that matrix is called diagonal matrix. How to define diagonal means DIAG. DIAG of, like this we can this is the full form of that this matrix, diagonal matrix. And another point we remember, sometimes they given one diagonal matrix here. For example, if A is equal to diagonal of D1, D2, D3, and so on, Dn, like that elements given, then we can find a power 4 or a power n. So how to find it means, just we can applying that power, that principal diagonal elements only, means d1 power 4, d2 power 4, and so on, dn power 4. Okay, now easily we can calculate that value. So easily we can calculate that value. Sima, for example, A is equal to, which matrix they given here? A is equal to 1, 2, 3, sorry, 0, 2, 3, 0 given. So this value can be represented. So this one, so A is equal to, we can write on here, A is equal to 1, 0, 0, 4 given. Now can find out this matrix A power 5. So simply we can write on, this is the diagonal matrix, means 1 power 5, 0, 0, 4 power 5. That value how much given? That is the value of that A power 5, when that is the which type of matrix? Diagonal matrix. Okay, na? Right. So that is the diagonal matrix. So after then we can learn another definition there, identity matrix. Identity, or this is also called unit matrix. Identity matrix or unit matrix. So this definition also same. In any square matrix, all elements are zeros outside of the principal diagonal. In any square matrix, outside of the principal diagonal, all elements are zeros. The elements in the principal diagonal must be equal to 1. Must be equal to 1. Means, for example, we can take A is equal to, now 1, 0, 0, 1. B is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Now here, Sima, this is the 2 by 2 matrix. This is the 3 by 3 matrix. Now this matrix is called identity matrix or unit matrix. So why you called identity matrix or unit matrix means, in the principal diagonal, out of the principal diagonal, all elements are zeros. Means here 1, 2, 1 there. Out of this principal diagonal, all elements are zeros, but the principal diagonal elements are must be equal to 1. Now here also same. Here same, principal diagonal, out of elements, outside of the elements, all are zeros. Principal diagonal elements are equal to 1. Then that matrix is also called identity matrix. Generally, identity matrix is denoted with I letter, I2. This one what? I3. That suffix we can define the number. That is the order of the given matrix. That is the identity matrix. Okay, now another one is scalar matrix. Scalar matrix. So what is scalar matrix? In a square matrix, outside of the principal diagonal elements all are zeros, but the principal diagonal elements all are same. Principal diagonal elements all are same. Then that matrix is said to be scalar matrix. For example, A is equal to 2, 0, 0, 2. Next, B is equal to, we can write on here, 1, 0, 0, sorry, 4, 0, 0, 0, 4, 0, 0, 0, 4. Now what we observing, Sima, here? This is the principal diagonal and this is the principal diagonal. Okay. This is the principal diagonal. So except the principal diagonal, outside of the principal diagonal, all are zeros. But in the principal diagonal elements, all are same. Then that matrix is said to be scalar matrix. Okay, na? So these are the three important definitions: diagonal matrix, identity matrix, and scalar matrix. Diagonal means what I told you. Outside of the all principal diagonal elements are zeros. The principal diagonal elements may or may not be zero. That is the diagonal. So in a square matrix, so all outside of the principal diagonal, all elements are 0, but the principal diagonal elements are equal to 1. So that is identity matrix. Scalar matrix means what? In the given matrix, so all elements outside of the principal diagonal, all elements are zeros, but the principal diagonal elements must be equal to same, or must be equal, or to equal to the same number. Here on structural, they given one structural definition there. Aij matrix given. Now this can be defined as two cases. I equal to j, I is not equal to j. In this matrix, I is equal to j means principal diagonal elements always I is equal to j, 1 given. I is not equal to j means 0 given. And another one, this scalar matrix structure means notation form we can define here. I is equal to j, I is not equal to j. I is equal to j means which numbers they given, Sima here? I is equal to j means always constant, not only 2, not only 4, some constant value given. That's why I consider k value. I is not equal to j means outside of the number, that value is equal to 0 given. So this is the notation form of the definition of identity matrix and scalar matrix. Okay, na? Now, uh, so this is the main definition, sir. Depends on that principal diagonal. So another one definition there, triangular matrix there. In the triangular matrix, two types there: upper triangular matrix and lower triangular matrix. So triangular matrix is nothing but diagonal matrix. In any matrix, the principal diagonal above and below elements may be 0. Above and below diagonal elements may be 0. Then that matrix is said to be triangular matrix. Here, Sima, principal diagonal, this one. So this the above elements are zeros and below elements are zeros. Then that matrix is said to be triangular matrix. And here I told them already two type of matrices there in triangular matrix. One is upper triangular matrix, upper triangular matrix. Another one is a lower triangular matrix, lower triangular matrix. Okay, now upper triangular matrix and lower triangular matrix. Upper triangular matrix is nothing but we can take principal diagonal 1, 2, 3 there. So lower elements are zeros, 4, 5, 6. Lower elements are zeros. Principal diagonal below elements are zeros. Then that matrix is said to be upper triangular matrix. Principal diagonal above elements means this one we can take here 1, 2, 3 then so 0, 0, 0 and 0, 0. So this one we can take here 0 value means 0, and this one what we done here, Sima? 0 and 3 there. Okay, these values we can write on here. Numbers means 4, 4, 5, 6, any number we can consider. So principal diagonal above elements are zeros, that is lower triangular matrix. Below elements are zeros, that is upper triangular matrix. So this is the triangular matrix, depends on that principal diagonal only. Okay, na? So these are the main types of the types of matrices. So scalar, diagonal, after then this value. Then we can discuss that equality of matrices. When two matrices are said to be equal. Equality of matrices. Equality of matrices. When two matrices are said to be equal means, we remember 2 points are important. First point is that two matrices have the same order. Same order. Order means already we learned, discuss the condition, number of rows by number of columns. For example, A is equal to order of A is equal to M by N. Order of B also must be M by N. Okay, na? So order of two matrices are equal or same. First point, that one. And we can equate into the corresponding elements are also same. Corresponding elements are equal or same. Corresponding means what, ma? In the first matrix, first element is equal to second matrix, second element. First matrix, second element is equal to second matrix, second element. Means, for example, we can take here 1, 2, 3, 4 there, this matrix. And B matrix also must be written 1, 2, 3, 4 only. So now here these 2 points are satisfy any matrices. That matrices are said to be equality of matrices. First, the two matrices have the same order. After then, the corresponding elements are equal. Here, Sima, 1 there, here also 1 there, here also m2 there, here also 3, here 3, here 3, so here 4, here 4. For example, now I consider here m by n generally, but I can give the example for 2 by 2 matrices. The case at exam they given questions like this also given in board also they ask the questions. For example, a is equal to ab 3 4 and b is equal to b is equal to 4 7 4 7 cd given 4 7 cd. When a is equal to b, then find the values of a b c. When a is equal to b, then find the values of a b c. First we can search here, order is same, 2 by 2 2 by 2, then the corresponding elements are equal, means what about a here, here how much there 4, a is equal to 4, here b there, here value how much there 7, b is equal to 7, here c there, in this position value what there 3 there, c is equal to 3, 4 4. But this is a simple example, but they given some summations, some squares like that given in competitive exams. But this is board oriented, directly they given some equal matrices given, means then we can remember these conditions. Whenever two matrices are equal, first we comparing the order of the given matrix, after then we can check the corresponding elements are equal, then the two matrices are said to be equal matrices. Okay na. Next, another operating main operatings, here two operatings there. So one is addition of matrices, another one is a multiplication of matrices. So addition of matrices, we can define addition of matrix or matrices. Addition of matrices means we can choose any two matrices of the same order. Here that is the very important point. We can choose order of a matrix A is equal to suppose 3 by 4. Order of matrix B is also 3 by 4. We can choose the same order matrices, two matrices. Then we can obtained, or we can get the resulting matrix of the these two, a plus b, a plus b. So this is called a and b matrices, addition of the matrices. A and b are the same order matrices, then we can obtain a resulting matrix, a plus b is called the addition of the given two matrices. But that resulting matrix order also must and should be coincide with a and b only. Order of a plus b must be what we are getting here, 3 into 3 by 4 value. Okay na? So how to find it? Addition means we can add the corresponding elements. For example, we can take a is equal to, simple example means 2 by 2, 2 3 4 7 they given, b is equal to what they given, 1 2 3 7 they given. Okay na? Now we can add or subtract, both are same operating. Now we can add these two operators, a plus b. This is the resulting matrix of the given two, addition of the given two matrices. Now first way what we search here, this matrix order is 2 by 2, this matrix order is also 2 by 2, order is same. Now we can add these two matrices. First corresponding element we add with the corresponding is nothing but first element, for the first matrix first element is equal to second matrix first element. Now we can add 3 plus 2. Now we can add 4 plus 3. Here 7 plus 7. Now what we read on here, 3, 5, 7, 14. This is the resulting matrix of the given two matrix. This is the addition of this matrix. This order must and should be required. Remember, this order is also equating to the given matrices order. Here this order 2 by 2. This order is also 2 by 2. Okay na? That is the addition of matrix. That is simple only addition of matrices. But majority we can did mistakes here only in board also. Why means in fastness we can calculate. Sometimes we can write numbers different additions. Okay, right. So this is the addition of matrix. Here some properties there. Addition of properties, a plus b is equal to b plus a. Commutative property. Addition of matrices satisfies the commutative property, as well as similar property also. A plus b plus c is equal to a plus b plus c value. Associative property, commutative property and associative property. We can add any matrix with the null matrix. Again, if you are getting same matrix, so then at the time this is called, the null matrix is called additive identity. Null matrix is called what? Additive identity. Now we can add same matrix with the negative of that matrix, a plus half minus a, or a plus minus a plus a, that value must be 0. At the time this minus A is called the additive inverse of A. Matrices addition with respect to additive inverse of A value. So these are the properties on matrix addition. So addition is simple. First we can take two matrices, then with the same order we can add the corresponding element. Similarly, we can define the difference of the two matrices. Difference between any two matrices can be written as A plus half minus B. A plus half minus B. So here we also check the order of the given two matrices must be equal, and we can subtracting the corresponding elements from one matrix to another matrix. One matrix to another matrix. So this is the operations on matrices. The first one is addition and second one is a difference, subtraction. We can find out subtraction means here only 2 minus 1, 3 minus 2, 4 minus 3 and 7 minus 7. So this is the subtraction between any two matrices, and we can add addition of any two matrices means we can remember 2 points. So first point is orders is same. Then we can add or subtract the corresponding elements in the given matrices. Okay, na? Now that is the addition and subtraction of the given matrices. These are the operation, means these are the properties: commutative property, associative property, additive identity. Next, additive inverse of the matrices satisfying with respect to addition. Next, another one, matrix multiplication. Matrix multiplication by a scalar. Scalar is nothing but real number. Scalar is nothing but what, ma? Real number. Physics we learn that scalar, okay, na, vector. So physics means here scalar means what? Any real number. So matrix multiplication by a scalar means, with example we can understand this one. Suppose A is equal to 3, 4, 7, 9 given. 3, 4, 7, 9. Now you can want to find out this value. What is the value of 2A? What is the value of 2A? Now here simply we remember, one matrix is multiplied by with a number, that is the scalar. So now how to multiply means 2 into A means 2 into 3, 4, 7, 9. Whenever scalar multiplication means that number is multiplied each and every number in the given matrix, each and every number in the given matrix. Now if you are getting here values 2 into 3, 6, 2 4s are 8, 2 7s are 14, 2 9s are 18. So this is the resulted matrix. So capital A be any square, any matrix, and K be any scalar value. Then the multiplication between the scalar and the matrix, that resulted matrix is the multiplication by a scalar, matrix by a scalar. This process is called matrix multiplication by a scalar. Means any matrix is multiplied by any number. At the time that number is multiplied by each and every element in the given matrix, then the resultant matrix is the that obtained by matrix A and scalar 2 value. Similarly, we can take any number, no, not only 2, 3A, 4A, 5A, 7A. Then we can multiply each and every number in the given matrix. That process is called what? Multiplication. Multiplication, matrix multiplication by a scalar. Okay, na? So that is the matrix multiplication by a scalar value. So after then addition over, difference over, matrix multiplication by a scalar over, now we can apply the multiplication of matrices. This is very, very important. Multiplication of matrices. Okay, so in addition and subtraction, one rule there. Which rules are there? The two matrices have the same order, and we can add or subtract the corresponding element. In there we applying the addition and subtraction. But in multiplication, must and should be we can satisfy. Must and should be that matrices are satisfy one common rule there. So which rule means A and B are A and B are any two square matrix of the any two square matrices. A and B are any two matrices, and if AB is conformable or AB is exist, AB product is conformable or exist, then rule what means here? Then the number of column, the number of columns in capital A means first matrix. in capital A is equal to number of rows in capital B, means the second matrix. This condition is satisfied, then only we said it to be the given matrices product is defined or conformable. For example, A is equal to order of A is m by n, order of B is n by p. Now we can define AB is exist or not. Here simply we remember first matrix number of columns. First matrix number of columns is equal to second matrix number of rows. Now here n there, here n there. So that's why the product is must and should be exist. Then what is the order of the resulted matrix? This resulted matrix order, when the common number there, we eliminate that common number. Remaining number of rows by number of columns. N by P is called the order of the that producted matrix, or that producted matrix or conformable matrix. Here A order m by n, B order n by p. Then BA is also defined. BA is also defined or not. BA defined means rule what? Number of columns in the B matrix equal to number of rows in the A matrix. But number of columns here P there, number of rows here M there. So that's why B does not exist. Here what? B does not exist. BA value does not exist. Product does not exist. Only exist for AB value only. Understood this one? So here multiplication between any two matrices means in the first matrix the number of columns is equal to the second matrix number of rows. Then only the two matrices product is conformable or exist. Otherwise, the product does not exist. Then the resultant matrix order is also depends on that this remaining number of rows in the first matrix is equal to number of columns in the second matrix. But in this concept, they given previous questions given. Previous question, how they given, Sima? For example, we can take one previous question for K set. They given order of the matrix A is equal to some 3 by 4 given. Order of matrix A is equal to 3 by 4 given, and order of B matrix is equal to, order of matrix is equal to m by n given. Now AB order of AB is exist, and AB is exist. AB is exist. Product AB is exist, and order of AB is equal to, order of AB is equal to 3 by 7 given. 3 by 7. Now what is the order of AB mat? Order of AB is equal to 3 by 7 given. What is the order of B value? Then how to find it? Order of B value. Order of B value. See, A matrix 3 by 4, B matrix m by n. Already we know that AB is exist given. So these two matrices product is exist means rule what? Number of columns is equal to number of rows. So from this condition, m is equal to 4. From this condition, m is equal to 4. From this condition, m is equal to 4. Means m value is equal to how much? 4 value. Then here resulted matrix order what would have been? 3 by n value. OB order actually 3 by n value. But they given 3, order of AB also given. Here 3 there, here 3 there. Now what is the n value? 7 value. So finally B order what would have means 4 by 7. 4 by 7. So this type of questions given. So then we can applying that concept to multiplication concept, and we can find out the condition. So whenever multiplication between any two matrices is defined means the number of columns in the first matrix is equal to number of rows in the second matrix. The resulted matrix means remaining number of rows and columns is the